Okay, another thermochemistry problem here. This time we are given a balanced chemical equation. I should always check to make sure it's balanced. And we're also given the change in enthalpy here, kind of hanging off of the end there. So we got our change in enthalpy in kilojoules. This problem in particular is asking if we start with a very specific amount of one of our reactants in grams, we have excess of our other reactant, how much heat will be released, right? That's what we're asked to find, how much heat will be released. So when I look at this, first thing I notice is I've got grams of sulfur, but when I look at my equation, I see moles of sulfur. So the very first thing I should do is probably convert from grams to moles. That's a real simple fix. You guys have been converting from grams to moles at this point for a while now. All you need is your periodic table. Look up the molar mass of sulfur, which I believe is 32 grams of sulfur. This piece should not be difficult for you. All we're doing is just converting from grams to moles. Grams of sulfur will cancel here with grams of sulfur, and you have moles of sulfur up top in your numerator. Awesome. Great. Now I know how many moles of sulfur I have. But that's not all this problem's asking for. This problem's asking if I start with a certain amount of grams of sulfur, how much heat will be released. So the same way in the last unit, we were comparing, let's say, moles of our reactant to moles of a product. Now we can compare moles of our reactant to heat released. So it's almost the same idea here. It's almost kind of like looking at ratios. And I'm just going to tack on one more conversion here. If I have moles of sulfur in my numerator, the unit moles of sulfur has to drop down here in my denominator to cancel. So I'm going to put moles of sulfur. And then I want to know how much heat will be released. So that will obviously be measured this time in kilojoules. Where do I go to fill in these conversion factors, or these, I guess, ratios if you want to call it? I can see them in my balanced chemical equation. It looks like 2 moles of sulfur will release a very certain amount of heat, negative 791.4 kilojoules. So I'm going to go ahead and plug those values in. 2 moles of sulfur goes on the bottom. Negative 791.4 kilojoules goes up top. And now I'm ready to solve. Punch in your calculator. 6.44 divided by 32 times 1 divided by 2 times negative 791.4. That should get you the correct final answer. Some students like to just multiply everything up top. Punch in your calculator 6.44 times 1 times negative 791.4. Then hit divide by, and you divide by everything in the denominator. Divided by 32, divided by 2. Your final answer that you get should be negative, looks like I rounded here, 79.6 kilojoules will be released into the environment. It's okay that I have a negative value here for change in enthalpy. That just means it was exothermic, and obviously that means heat is being released, which is what the problem mentioned. This has been a Rodriguez original production. I hope this helped. Go back, study, practice, look at more examples. Good luck.